Graphing linear inequalities in two variables. So first remember that y equals mx plus b. M is your slope, and b is your y-intercept. And to find your x-intercept, you substitute 0 in for y. So for the first equation, my slope, which is m, will be 2 over 3, which means we rise 2, run 3. That's really bad. The y-intercept is equal to negative 5. The x-intercept will be 0 equals 2 over 3x minus 5. Add 5 to both sides, so we have 5 equals 2 over 3x times both sides by 3. We get 15 equals 2x divided by 2, so 7.5 is our x-intercept. Now to graph this, the easiest way, I should put this over here. First, plot your y-intercept, so 1, 2, 3, 4, 5. Now just use your slope and go your rise and your run. So up 2 over 3, up 2 over 3, up 2 over 3. And then you connect your dots. So for this one, to find our slope, we have to put it into y-intercept form. So we put our y's on this side and our x's on this side. So y will equal negative 3 over 2x minus 9. So slope is negative 3 over 2. Y-intercept is equal to negative 9 over 2. The x-intercept will be equal to whenever y is 0. So 3x plus 2 times 0 plus 9 equals 0. So 3x equals negative 9. Divide by 3, and x equals negative 3. So a second way to graph is to graph both your intercepts. So we have negative 3 is our x-intercept, and our y-intercept is negative 4.5. 1, 2, 3, 4.5. And then connect the dots. I don't care which way you choose to graph, as long as you are comfortable doing it. If it is in this form, the quickest way is to find your intercepts. If it is in this form, it's quickest to plot your intercept and then use your slope. For the following, graph the inequality x minus 3y is greater than 6. So we want to graph the line x minus 3y equals 6. Oops. So the quickest way to do this is find our intercepts. So for our x-intercept, we make y 0, so x minus 3 times 0 equals 6, so x equals 6. So that means at the point 6, 0, we have a point. Our y-intercept, we have 0 minus 3y equals negative 6, so y equals negative 2. So at the point 0 and negative 2, we have a point. Now, because this sign is a greater than sign, and it's not a greater than or equal to sign, we know that the line that we are going to draw will be broken, because it's not going to be included in the data. If we also wanted to include the 0 values, it would have this line underneath it. So we have a broken line. We're going to draw our axis, and then 0 and negative 2 and 6 and 0. 1, 2, 3, 4, 5, 6. And then we join them with a dotted line. Now, to choose which area we're going to shadow, so the region that is shaded in is the region that will satisfy the equation. So that means anything that will be shaded will work in the inequality for x and y values. So we want to test the origin. So test the origin. You can choose any point. The origin's the easiest. So we're going to substitute an x equals 0 and a y equals 0 into the equation. So 0 minus 3 times 0 is greater than 6. 0 is greater than 6. Now, if this is true, we would include the region with the origin. But because this is wrong, this does not satisfy the equation, we know for sure that the origin doesn't count. So if that point doesn't count, none of the points above the line are going to count. So we shade the bottom region. So I don't care how in depth you shade, as long as I know which side you are shading. Okay, the word problem. Carmen has up to $15 to buy seeds. A package of vegetable seeds costs $1.50. A package of flower seeds costs $2. So let's let V equal veggie, so the vegetables, and F equal flower. So we know that a vegetable seed costs $1.50, flower seed costs $2, and she only has $15, so it can be less than or equal to 15, as long as it doesn't go over. So we're going to graph this line. The only thing about this one is that we can't actually shade the region that we want, because we can only have integer values, because you can't get half a bag of seeds. So we're not actually going to shade our region, but we're going to test for our region and then choose points. So we're going to graph the line 1.5v plus 2f is equal to 15. So let's find the v-intercept, which is when f is 0. So 1.5 plus 2 times 0 equals 15. So v is equal to 10. And the f-intercept will be 1.5 times 0 plus 2f. So f will be equal to 7.5. When we graph it, it doesn't matter which is your v or your f axis as long as you label them. So I'm going to label v and f. So we know when v is 10, so let's make these go up by 2, 2, 4, 6, 8, 10. We have a point, and at 7.5, so 2, 4, 6, 7.5. So right in here, connect your lines. Now we're going to test our origin. So 1.5 times 0 plus 2 times 0 is less than or equal to 15. 0 is less than or equal to 15, so we want anything in the lower region. So if we want to choose two values, let's choose this one and this one. Let's call this A and B. A will be at 2, 2. And we can check to see if this works. 1.5 times 2 plus 2 times 2 is less than or equal to 15. So 3 plus 4, 7 is less than or equal to 15, which is right. And B will be at 4 and 2. So 1.5 times 4 plus 2 times 2 is less than or equal to 15. So 6 plus 4 is 10, which is less than or equal to 15, so that's right. So any combination, anything underneath here will work. Question C says, can Carmen buy 5 packages of vegetable seeds and 4 packages of flour. So all we do is we find 5 packages right here and 4, so it's above our line, oops, right up here. So for C, no, she can't. And it's really just because you read it on the graph and it wasn't in the right region. And what is the most money Carmen can spend? So we want to choose a point that's really close to the graph and not touching. So let's go here. So that looks to be about 2, 4, 6, and 2. So we plug this in, so 1.5 times 6 plus 2 times 2 is less than or equal to 15, which is 13. So the graph's gone again. So she can spend up to about $13 from our graph that we've drawn without going over. So choose a point as close as possible to the graph without touching it.